Good day, grade 12s. I hope you are fantastic. Welcome to another exam revision lesson. My name is Tiamo Peu and I'm going to be your tutor and teacher for the day. I am a senior tutor for mathematics at Learning for Mastery Academy. I hope that this lesson is going to benefit you greatly and that it can contribute to your critical thinking in the subject of maths, and also just provide you or assist you to have a better comprehension of mathematical problems. Now, without any further ado, let's get into the work of the day. Today, we're going to be looking at algebra. The questions that I have here are drawn from the final exam, the 2020 November exam. It's only question 1. If you check the exam, it goes up until, I think it's 1.4, 1.5. However, I excluded the last 2 questions of question 1, primarily because I'm going to create a separate video for what I refer to as high order questions, okay? And I strongly believe that the last 2 questions of the November 2022 paper are high order questions. In this particular video, we're only going to cover what is common, okay, which is just the mere solve for X questions and then the simultaneous question. I hope that we're going to have a lot of fun discussing this, and you're going to have fun just learning from us. Now, let's get into the first question. So, the first question, as you see here, it says solve for X, okay? Now, this question, it's very straightforward. However, it can get a bit tricky at times. So the one that they've provided us with, like I said, it's very straightforward. What you're going to do here is, remember, usually or previously in grade 11, they would give you a normal quadratic equation such as this, x squared. I'm just making an example. So I'm going to pick something that's a lot easier to work with. So they would give you x squared plus 2x minus 3 equals to 0. And then what do? You would then open 2 brackets, equate them to 0. This would be x plus 3, x minus 2. See? Now, if you look at this step, the factorization step or the expansion step, and you compare it with this, you'll realize that it's actually the same thing, right? It's exactly the same. And usually under this question, what we would do, following from here, we would just equate each of these brackets to what? To the 0 on the other side, right? It would then give us x plus 3 equals to 0, x minus 2 equals to 0. Now, coming back to the question that we are provided with, we're going to do essentially the same thing, right? We're going to equate the first bracket, 3x minus 6, we equate it to 0. Then we put O, and then we copy the second one, x plus 2, we also equate it to 0, okay? Then from here, you have 2 linear equations. What do you do with them? You work them out. Let's start with the 3x minus 6. Transpose the 6 to the other side. You're going to have positive 6. You divide both sides by 3. X ends up being equals to 2. And then on the other side, you're just going to transpose the 2 to the other side. It gives you negative 2. Okay. Now, this would be your solution. However, in some instances, what they will give you is they will do something like this. I'm just going to write here. I'll erase it later on. They will give you 3x minus 6, open bracket, x plus 2. And then on the other side, they don't give you 0. They give you something like, let's say, negative 2. Okay. In this case, you cannot, and I emphasize this, you cannot equate each one of the brackets to the negative 2. Okay. The same way, if you are given something like 3x squared plus 4x equals to 3, for example, you can't factorize this and then equate whatever you terms you have or factors you have to the 3. Okay. First step is always to ensure that one side of the equation is equal to 0. So you would transpose this to the other side. Then you'd end up with 3x squared plus 4x minus 3 equals to 0. All right. Then after this, that's when you factorize. Okay. So you only start solving for x when one side of the equation is equals to 0. As long as both sides are equivalent or are equal to anything except 0, your task is to just simplify the equation to ensure that one side is equal to 0. Now, the same idea applies here, okay? Both sides are not, or neither one of the two sides is equal to 0, okay? So the goal now, the task, is to simplify this in such a way, or to an extent, that one of the two sides is equal to 0, okay? So the question is, sir, how would we work this out? Simple. You FOIL this, right? You get rid of the brackets. It's going to give you 3x squared minus 6x plus 2x equals to negative 2. How did we get, sorry about that, I made a mistake. Then it's going to give us minus 12 equals to negative 2, right? How did we get this? You just distribute it there. This goes with that, okay? And then once you are here, what do? Then you can bring the negative 2 to this side. You'll then end up with 3x squared. These two will give you minus 4x. Bringing the 2 to this side is going to be minus 12 plus 2, which gives you minus 10 equals to 0. Now remember, this is just a rough question. I just took this from the top of my head, okay? So there's no, it might maybe not have solutions. If it has solutions, speak up, but I'm not going to work it out to the end. I was just trying to emphasize the point that if the other side is not equal to 0, you cannot equate each one of the brackets to whatever value you have on the other side, okay? The idea is, if it's not 0, you simplify the brackets, then you transpose the number to join the expression or the quadratic expression, so that the one side can be equal to 0. I hope that is clear and that you understand it, okay? But the question that we are given here, it's a lot easier. The one side is 0, the other side you have two brackets, right? Those two brackets, remember, are factors of a quadratic expression, okay? If you work it out backwards, you will ultimately end up with a quadratic expression that when you factorize, you end up with these two factors or these two brackets, okay? Now, this is going to be your final answers. It's going to be x equals to 2 and x equals to negative 2. I hope that is clear. Now, let's move on to the next question. Question 2 says, solve for x when given 2x squared minus 6x plus 1 equals to 0. Correct to 2 decimal places. Now, very important, okay? When they give you this in the exam, you have to know what it means. Correct to 2 decimal places. What does that mean? It can only mean one thing. It means use the quadratic formula. Okay? Use the quadratic formula. X equals to minus b plus minus square root of b squared minus 4ac all over 2a. Now, in grade 12, you don't have to show all the simplification steps of your quadratic formula. You can just copy the original formula like I did here, and then do the substitution, then move on to your 2 possible values of x, okay? So, quadratic formula, I usually just pick out my a, b, c before I substitute them. Now, remember, when you pick out your a, b, c, you take them along with the operation in front of the number, okay? So let's start with a. A is going to be 2, b is going to be negative 6, and c is going to be 1, right? Then we can substitute this. We're going to say x equals to minus open bracket negative 6 plus minus negative 6 squared minus 4 2 1 all over 2 2. Then you can put this in your calculator, get your values of x. I also have, right, so when we take the positive, when we use the positive, our answer becomes 3 plus root 7 over 2. And then now we're going to use the negative. When we use the negative, I'm trying to color code them. Our answer becomes 3 minus 7 root 7 over 2. However, what was the instruction? The instruction was correct to 2 decimal places. Then you're going to come here, say equals to. You can change this. Okay, perhaps let's start with this one here. It's going to be 0.1. These are 2 decimal places, so it's going to be 1/8. And then we come here, change this to a positive. What does it give us? It's going to give us 2.82. There we go. These are your 2 possible answers for question 2. Okay. Always remember, when they say correct to 2 decimal places or correct to 3-4 decimal places under solve for x, that simply means that use the quadratic formula. Okay. Now let's proceed. The next question we're going to look at is inequalities. Okay. Inequalities, very complex but easy topic. I hope that my approach and how I'm going to explain it now will perhaps provide clarity for you, so that going forward you don't struggle with these type of questions. Okay, now let's get into it. With inequalities, it's essentially 2 things. You have to solve for the critical values, right, which simply means that you work it out the same way you would work out an equation to solve for x. After that, once you have your critical values, then you have to draw a number line. Okay, the number line will then lead you to your final answers, which will be interval or intervals. Okay, now let's get to work. So first thing first, we have to work this out and get the values of x. We then gonna say x squared. We transpose the x to this side. It's gonna give us minus x minus 90 greater than 0. Okay, then we have to work this out. It's going to give us 2 brackets. Gives us x. Then we're going to have minus 10. These are the factors, plus 9. And then we get the critical values. We say CVs, okay? CVs, x equals to 10 or x equals to negative 9, right? This is the first step. Then we have to move over to the second step. In the second step, this is where we draw our number line. Okay? We're going to put the smaller one on the left, minus 9, and put 10 on this side. Now, what we're going to do here is we need to identify, as you can tell, our number line has 3 sections. Okay? We have the first section. Maybe I should color it with a different color. Let me use blue, right? There it is. And then the middle one, we're going to make it orange. And then we have red on the far right. There we go. So now, the blue section is going to have its own sign. Then the orange, same. The red, same. Okay? So we need to figure out what is the operation for the blue section. Okay, how do you check that? It's simple. You go back to your equation, which would be this, right? You come back to this. Now you're gonna pick any value that is less than negative 9. Okay, on the left of negative 9, any number that is less than negative 9, you place it in place of x in x squared minus x minus 90. Okay, Why do we do this? We do this to check that if we substitute a number less than -9, would the answer be a negative or a positive? Okay? That's what we are checking for. So now, I'm actually going to try two numbers that are less than -9. I'm going to try, let me try negative 12, right? I'm going to try negative 12, say negative 12 squared minus negative 12. You can do it with me as well. While I'm doing this, you can pick your own number and substitute it as long as it's less than -9. When I substitute negative 12, I get positive 66. Okay? When I substitute negative 12, sorry about that. Let me write this here. When I substitute negative 12, I get negative 60. I meant to say positive 66, right? Gives me 66. Now, let's try another one. Maybe further down, negative 23, right? Negative 23 squared minus negative 23 minus 90 gives us, I'm going to come here, 23, come over here as well, 23, that gives us 462. So you can try your own numbers, but you'll notice that when you substitute any number less than -9, your answer becomes a positive. So then we're going to mark this section as a positive. We'll say that section is positive, okay? Meaning, whatever value you pick from the blue section, because remember, the number line represents possible values of x, okay? So it simply means that whatever x value you pick in the blue section, when you substitute it into the equation, it's going to give us a positive answer, okay? Now, perhaps before I proceed, let me just quickly come back here. Basically, what's happening here is we are looking for values of x that can make this expression over here a positive. Why? Because we have the expression being greater than 0. If it's greater than 0, it means that it's a positive, because a positive is greater than 0. Do you understand? So we are looking for values of x that can make the expression positive or greater than 0. So far, we know the blue section can make it a positive, right? I've tried my numbers. I'm pretty sure you've also tried your numbers, okay? Now, let's go over to the orange section. The orange section, it's numbers between -9 and 10. I'm going to pick, which number can we go with? Let's take 5, right? We're going to take 5. As you can tell, I'm just picking random numbers. It gives me, when I substitute 5 here, it gives me -70. Let's pick another one, 7, for example. 7. Or -7. -7. It also gives us a negative. See? It gives us -34. There we go. Meaning the middle section is a negative, right? Then we proceed, go over to the last section, the third section. A number that is greater than 10. I'm going to go with 23, positive 23. 23. It gives us 416 positive. I'm not going to write it down on the screen. I'm going to try another one. 14. 14, there we go. It gives us positive 92. So this gives us positive answers. When we substitute numbers that are greater than 10, our expression becomes a positive, okay? Then we have now labeled all the 3 sections. We then have to draw our pointers to indicate which section or sections of the number line supports the question, supports expression greater than 0, okay? Or x squared minus x minus 90 greater than 0. Which section or sections of the number line supports that statement? Because remember, algebra is all about statements. Even equations, they are statements. It's left hand side equals to right hand side. In this case, it's left hand side greater than right hand side. Or not greater than right hand side, but greater than 0. Okay, so which section or sections support that statement? Simple. It's going to be the blue and the red. So what you're going to do is you're going to draw your own teeny tiny circle there, right? Then you draw arrows towards those sections that support the statement. I hope that is clear. You draw your arrows towards those sections that support the statement. Okay. Now, before I proceed to get the final answer, let me just make this note. The circles that I've drawn, these small circles, sometimes you might have to shade them. Okay. But the question is, when do we shade them? You shade them when it's greater or equals to or less or equals to, right? So if our inequality was less or greater or equals to, we would then have to shade these. Okay, but now that is not the case. That's why we leave the circles unshaded. Okay, I hope that is clear. From here, we can then move over to the final answers. What we then going to do is we're going to say x, right? We take the direction of this arrow, we place it here. Then we say x on the other side. We take the direction of this arrow, we place it there. Then you take their respective numbers. -9, put it here, or take 10 on the other side, you put it there. Meaning, x is either less than -9 or x is greater than 10. Meaning, if you pick any number that is less than -9 or greater than 10, your expression, and you substitute it into the expression will be greater than 0. Okay, I believe that I have over explained this. I hope that you understand it. Okay, now let's move on to question 4. Question 4 is surd equations. Okay, so now the question is, how do we work this out? All right, it's simple. With this one, we are going to, firstly, we have to get rid of the square root. How do we get rid of the square root? It's very simple. Remember, a square root is basically an exponent of a half, right? It's 1/2, right? So what we're going to do here is we're going to say x minus 7. We change the square root of x to x to the power of 1/2 equals to 12, right? Or let's so much just transpose the 12. We bring the 12 to the left hand side. It gives us that equals to 0. Now, why did I do all of this? I did all of this because we are going to use the K method. But I don't like to use the K method personally, so I'm going to provide you with both solutions. So we're going to say k equals to x to the power of half. Therefore, k squared is equal to x. Okay, k squared is equal to x. Why do we say k squared is equal to x? It's because x is equals to x to the power of half times x to the power of half, and k squared is equals to k times k. And remember, what did we say? We said these guys are equal. X to the power of half is equal to k, and x to the power of half is also equals to k. Meaning, multiplying these two is technically multiplying these two, which would then lead you to k squared. Okay, I hope that is crystal clear. Yeah, this won't be workable. So the 12 actually has a negative. It's -12 there. I'm sorry about that. So then you can transpose the 12 to the other side, which will give you a positive, which means this here is going to be a positive. Now, when we okay, so now after changing all this, this makes more sense. So what we then going to do is we're going to have minus 4 and 3, right? Which means k equals to positive 4 on the other side. K will be equals to 3, right? We're not done. We then have to work out the values of x. Remember, what did we say? We said k is equal to x. So we're going to have x 1 over 2 equals to 4. On the other side, have x 1 over 2 equals to 3, right? Then we can apply the reciprocal, or we can just square both sides. I think that should work. This side we do the same thing, square both sides. The squared will cancel the half. You have x equals to 16 here, or this cancels that, x equals to 9. But another thing that I have to emphasize with question 1 of your paper is, after you get, especially with equations, after you get the possible values of x, it's always advisable to substitute them back into the equation to check if they give you left hand side equals to right hand side. Okay, sometimes, yes, you can calculate the answers and you do everything correctly, but you find that one of the solutions is not applicable. Okay, so what we're going to do is we're going to take the 16, substitute it into the equation. So we're going to open bracket 16 close bracket minus 7 square root of 16. If it gives us negative 12, it does give us negative 12, right? That's perfect. Then we try the same thing with the 9. It also gives us negative 12. Therefore, both these answers are applicable. Okay, very important. Whenever you're solving for values of x, always check if the final solution that you get is applicable. Okay, so I'm really sorry about the typo there. I just didn't see it. I'm so sorry. Right now, let's proceed over to the next question. I haven't forgotten about the second method for this question, for question 4, the alternative. I will maybe discuss it on a different video, because as you can see, the space is already filled, and I think this is the method they used in the memo for the question paper. So as we go on, as I provide more videos for you guys, I will just provide various types of or various alternatives so that you guys can have more methods to use. I usually just say to my learners that you are better off knowing different methods of working out one question than just knowing one method, because what happens if you forget that one method? You have nothing else left. Do you understand? So I will provide, just not in this video. I'm really sorry, but on another video I will make sure that I include the alternative method, particularly for these type of questions. Okay, now let's go to the simultaneous equation. The simultaneous equation, here's what we are provided with: 2x minus y equals to 2, and we're also provided with xy equals to 4. So what we're going to use here is the substitution method, right? So we're going to call this our equation 1, then call this our equation 2. All right, then we will have to derive equation 3. I'm going to derive equation 3 from which one can I use? I'm going to use equation 1, right? I'm going to make y subject of the formula. So I'm going to say negative y equals to 2 minus 2x. Divide everything by negative 1. Y equals to negative 2 plus 2x. I'm going to call this equation 3. Okay. Then I'm going to say substitute equation 3 into equation 2. Okay, then from here I'm going to say equation 2 is xy. I'm going to say x open bracket negative 2 plus 2x equals to 4. Then I FOIL this. There we go. right? Then this is going to give me negative 2x plus 2x squared equals to 4. Again, we transpose the 4 to this side. Then I'm going to arrange it in the correct order. Start with the x squared, which will give me 2x squared minus 2x minus 4 equals 2. Thus, we can then divide everything by 2, which will then bring me to x squared minus x minus 2 equals to 0. Let me write this x properly. There we go. Then from here we can get the factors, open bracket, x minus 2 plus 1, x equals to 2, or x equals to negative 1. Then we can substitute. So to get the y value of 2, it's going to be y equals to negative 2 plus 2. This gives us 4. 4 minus 2 gives us 2. So these two will be 2 and 2. We come here, y equals to negative 2 plus, 2, negative 1. This is going to give us negative 2. Negative 2 gives us negative 4. Therefore, the coordinates will be negative 1 and negative 4, right? Now, simultaneous is basically, in functions, we call it the point of intersection, okay? The point of intersection, all right? So, for today's lesson, as you can see here at the bottom, it says 3 out of 3, right? So this is the last question for the day.